Most of you are excited to go stand in line to check out, go stand at the airport, have to take your shoes off, and who knows what now with the TSA. So I'm John McCrae, I'm from Nevada, and I'm the UST supervisor for the state. And we'll be talking about today new UST installations. I have our first presenter is going to be Mike Gerente from New Hampshire. He supervises the oil compliance section of the New Hampshire Department of Environmental Services. Then the oil compliance section is responsible for all aspects of the above ground and underground storage tank leak prevention program, as well as the vapor recovery and safe tank programs. Mike has been involved in the tank program for the past 17 years, and before that worked in solid waste, air resources, and the Department of Transportation. He served on the Ashwamo UST Task Force and the Federal Regulations Work Group, and is currently a member of the National Work Group on Leak Detection Evaluations. He's a registered professional engineer and received his bachelor's degree in mechanical engineering and his master's degree in civil engineering from the University of New Hampshire.
Thank you very much. Good morning, everybody. He did leave out my likes and dislikes.
Just say that.
Likes. I like 2 a.m. walks along the boardwalk. I like Killer Harmonica. Mr. Gentleman in the 4th row there. Killer last night. That was good. Turn-offs, water and sumps with a sheen, and only going as high as the lowest penetration in the sump. Monitoring panels with their alarm muted for many, many months or more. And as you can probably tell, I'm an engineer. You can tell by the uniform that I'm wearing. But anyhow, enough of that. I'll proceed. I plagiarized this slide directly from the agenda that went out, so this was the easiest slide. I got this one done a long time ago. All the rest I kind of finished a day or two ago. But basically, we're going to go on. We have a tank comes in, tank goes in the ground. Boom, what could happen? So what I'm going to talk about here. So what I'm going to talk about here is that once it's in the ground, you're pretty much just rolling with whatever you get. You're going to roll with the punches. So what can we do to make sure that when it's going into the ground that it's got everything it should have and meeting all requirements and not otherwise becoming a political hurdle or something to get compliance at that facility. So a few more points to add to what is in the agenda. Just a couple items that you might want to think about wondering or making sure that taken care of before that tank goes in. In a few states, my state, we were fortunate enough that when the tanks program started back in the 80s, because of all the tanks are leaking pretty profusely into the ground at the time, we had support through the legislature with our UST rules to also adopt plan review construction approval requirements. So before any tank can go into the ground, we need professional engineers submitted plans coming to the state. We review that. We have usually at least 1-2 iterations with the applying engineer before they get a construction approval. You can't put a shovel in the ground until they have that construction approval. Why is that good? And why should most owners enjoy that step? The biggest thing is shared expectations. If you have plan approval and everything that's on the plans then the owner knows that if he just installs it per the plans, there's not going to be any surprises, there's not going to be any delays. As soon as that's all installed, they get the final inspection, he's in business. There's no surprises. So what are some things we look at when we get a plan review? And one of the first things is public water supply systems, wells. There are certain setbacks in DES. In New Hampshire, we have the sanitary protective area, we call it, around public water supply systems, and also setback requirements for private wells. First, you'd be surprised at how many folks are trying to put their UST system within the zone of influence of radius of depression of that well. So that's one of the first things we look at. We feel that if you're trying to make coffee in your convenience store, that coffee should be without a flash point. So Other things, building setbacks. A lot of folks want nozzles to be able to go in the front door of their C-store for some reason, or in a window. The different setbacks we look at are NFPA 30 and 30A as setbacks. And so, again, to avoid surprises, we don't want to get there on the last day and say, hey, you can't have that dispenser there. So ahead of time, we know that all the setbacks are met. Other things, folks sometimes like to install parts of their systems on other people's property, so that we can be a clearinghouse for that. One of the biggest things we're seeing right now is right-of-ways for highways, especially where we had the 2015 deadline for closing single-wall systems. So we have a lot of these old systems where half the tank might cross the right-of-way, or the dispensers, people might be fueling on the shoulder of the road. Now, once we're going through plan review to upgrade those systems, those are some of the things we look at. In some situations, they are able to work with the Department of Transportation, get an easement or whatever to do that in the right of way. But just, again, a very important thing to nail down at the very beginning before you get into the process and find out you've got to move everything because you're in the right of way of the highway. We require that all tightness tests be spelled out on the plans. We don't want to arrive for a backfill inspection and find out that somebody has done a test that we're not accepting, and then they have to go through, reschedule, do the test, and we come back. It's just wasted time, wasted effort. We also want to make sure that the tests being done are the most stringent that you would expect to have done in that system. You don't want to go up and do a test that is easy to pass. You backfill, pave over, and you come back and do a little bit more stringent test and it doesn't pass. So for piping, we typically go with the more stringent manufacturer's requirements for that. As far as a lot of the manufacturers of piping are really good now at spelling out all the tightness testing requirements. So we get those right on the plans so the installer knows what they have to tightness test to. As far as some tightness test methods, we don't allow PEI 1200 in the state. As Matt was talking about yesterday, we require to inch from the top, and we have a 3-hour wait with no measurable loss in water column during that test. Being nerds, we did our calcs and we found that for 36-inch diameter sump, doing a PEI test, you lose 1/8 of an inch. That's about half a gallon an hour of loss. Even more so than that's with water. So if you have a less viscous product like gasoline, you expect a little higher loss. As far as height, if you're 1 inch above the penetration as opposed to 4. If you're 4 inches above, then it's 400% more pressure on that entry boot than if you do the 1 inch above. That's the inches matter when you're doing tests. We've done a lot of tests where we've gone through and done the PEI 1200 and it passes, and then we fill it up a little higher and it doesn't pass. It's just that little bit extra will open up whatever the issue is with that boot and identify that. So again, we want, because that's more strenuous test, we want that done at installation to make sure it's tight, so before they backfill everything up and stuck with a sump that they have to redo. Product compatibility plan review is the perfect time to check, make sure that whatever concentration you're doing, that all the items you're specifying, components have the proper UL listing for that. We also look at other items that aren't necessarily given by or stood by industry, like piping compatibility, UL 971, that's easy. In tanks, the manufacturers have really good literature and show that that's no problem. But a lot of the details, like sealing around sumps, sealing around pipe penetration boots or sump penetration boots, in the past, a lot of people were just putting on a lot of Bostic around that. We checked with the manufacturer. Bostic's not compatible with ethanol long term. They don't recommend it for that. We pointed that out. That was during the whole plan review. We've come a long way in what we look for since the mid-'80s, and we're always finding things that in the field we find don't work, and releases were caused because of that. And we go through and we look at that and kind of step up what we look for in plan review. Bostic is an example for that. You need to have a compatible sealant, and most manufacturers of boots say don't put any sealant on the inside. You can put a little on the outside. But it was like a common practice for all contractors, they were just putting all that Bostic on there, even though the manufacturer said you couldn't. So it's just another example of product compatibility things that we look at when we're doing the design review. It's a chance to make sure that secondary containment is complete. We look for everything to be specified, make sure that the piping entry boots that are being specified are compatible with mechanically with the sump that they're going to be installed in, with the piping that's going to go through it, just to make sure that we're going to have complete secondary containment. One of the things we look at in plan review, an example is self-structural tanks, where they're coming in, they're doing a tank-in-a-tank construction. We found that from one of the installers that we had in the state that it's their common practice, even though the UL listing shows that the new double wall tank is completely 360 degrees new, it was their common practice to just glass up to the top of the tank, the steel tank or whatever tank was there, using those same bungs and everything, just going up to that. So in the plan review process, we were able to specify, that is, you have to cut out that top roll bungs and you have to go up with a 360 degree new tank. Just one of the other things we caught, and we had shared expectations so that when we got there to do backfill, if we saw original tank material, they would have had to start over again, basically. And properly installed manways. If you're going to do, a lot of the older tanks don't have manways in them, so if it needs to be repaired or entered for lighting or whatnot, then people need to dig that up. They'll cut a hole in the top and they'll put something on there for a manway to seal it up after. There are UL standards for manway installations that need to be followed, and we can ensure that they are putting in a proper manway before they get in and try and bury it up and have to go back and visit it. And other little things like overfield protection height, that's specified, that we calculated ahead of time. That gets trickier when you are having siphon tanks of different sizes. You want to make sure that the crowns of the tanks are all at the same height, and sometimes it affects the fill protection heights. You want to have it at the lowest allowable level for both tanks. And that's all stuff we can ensure for common expectations. And another thing is we can avoid issues that are going to be chronic issues in the future. For an example, we look at parking lot pavement heights. We look for all the elevations of the tank. And for one of the issues that we are able to avoid is a type of facility where the parking lot might slope down towards one of the sumps and it's chronically full of water. Once it's there and done, it's kind of hard to... People spend a lot of energy trying to seal that up and raise it and stuff, and just have from the very beginning make sure your pavement plan is such that you won't be directing any surface water at the tank top pad or dispensing area. We ensure that the tanks, the anchoring is properly planned out. If there's groundwater going to be encountered in excavation, that there is a dewatering permit that they have so they can dewater that, safely install the tank, anchor it down without it moving. We prohibit ballasting with fuel. We're not, by rule, you're not allowed to put fuel into a new system until everything is completely done. One of the problems with fuel is, ballasting with fuel is if that tank excavation is then fills with water, that tank's still going to float because gasoline has the lowest specific gravity than water, so it's still going to go up. So try to avoid having to ballast, but if you do have to ballast, it's got to be water. And we can also avoid other problematic configurations. We can look at where the tank pad is located, entryways on the road, make sure that the trucks are going to be able to, cargo trucks will be able to get in and safely deliver fuel in a manner that the hoses aren't going to be hit by automobiles or other folks going around, just trying to prevent a bad situation. And another thing that we've seen proposed is dispensing area drains. We require an impervious dispensing pad with positive limiting barriers around the periphery. And sometimes we'll get plans in where you have a concrete or a concave dispensing area with drains that pipe underground to oil water separator, which then daylights out in the back of the property. And that's a chronic issue for us because of our release reporting rules and cleanup rules. If any spill is not immediately cleaned up, it's a reportable spill that has to be immediately cleaned up. So if you were to have a little mishap at the dispenser and a little bit goes in that drain, now you can't put Speedy Dry and immediately clean it up. It's into that oil water separator, and by our rule, they have to go and suck out that oil water separator, or not. Nobody's authorized to store product in oil water separators that aren't otherwise permitted, that are double wall with leak monitoring and all that type of stuff. If you require all that for the storage tank, why would you allow it to be stored in a single wall oil water separator? So in those situations, we just give a little outreach to the owner and tell them what they're in for, operations wise, every time there's a little spill. And usually the cure, if their business model is to have an oil water separators, then that would be like another first line of defense outside of the pad. If something was to get onto the pavement or overflow that pad into the oil water separator, then that would help keep the bulk of that fuel out of the surrounding water, ground, but it would need to be immediately cleaned up out of there. I don't have a picture of a drain in a dispensing pad, but we have some older sites where there's a drain in a fueling pad, in the tank pad, and off to oil water separator, which is never cleaned and nobody knows what's coming out. The problem with the oil water separators is they don't separate the bad parts, the worst components of fuel from fuel. So what's coming out, you can't drink. I mean, there's benzene and toluene, methylbenzene, xylene, all those things are in that. And also, if there's any surfactants used at the site, any type of soap or anything, then you have that emulgates a little bit, and you're actually having more of the other components come out also that aren't separated. So just things that we've seen problems with that we seek to avoid during the plan review process. After we get approval and the construction takes place, the folks go out, do all the testing. The engineer is required to look at the system, make sure it's installed per their plans. That's kind of hit or miss. There's good engineers, bad engineers. A lot of things can be caught at the time. More often than not, where we go out to do the backfill inspection, we find things that aren't per plan, different type of piping or different type of entry boots or different routing of piping, and that will halt things, and we have to go back to the drawing board and make sure that it's okay. One of the big things we look for is dog legs on fiberglass piping. You're going to have the 4-foot dog leg at any type of hard connection. We look for that. We don't always find that. Sometimes I got to go back and reinstall. Big thing, backfill inspection, bring a level with you. Here's a picture of one of the newer facilities with a very wide-reaching piping runs. Obviously, this one is not ready to continue the backfill. The piping isn't at a continuous slope in all areas, but we'll go out on the longer runs and put the level down and find out where we have high and low points throughout the run, and they have to go through with the detail and make sure that the piping all drains back evenly. After that final approval is done, then we'll go out for the final inspection. At that final inspection, we'll check other NFPA requirements like proper check valve height in the dispensers, make sure that the fuel nozzles don't go beyond the edge of the paved dispensing area. Just little things like that. We'll go through and test all the leak monitoring sensors, make sure they're all labeled on the leak monitor panel, and just make sure everything's appropriate and good to go. It's just like an operational appliance inspection at that point. And everything's good to go, and they're registered and per plan, they get their approval. We do have a requirement for repairs, that if a repair to a tank of piping is going to be made, that we get notified. It's not really a plan approval process. It's more of a notification of this is what we intend to do, and they're required to provide the manufacturer's expression of that they're okay with that type of repair before it's allowed. One good thing about the notification is oftentimes we can find items that are actually a plan review requirement, not just a notification, and so we can alert them of that ahead of time so that they don't have to dig up what they just did. Again, it's all common, shared expectations and avoiding surprises is what it's all about. In summary, I guess I'm doing good for time. Nobody started to eat my sandwich. That was going to be my indication I needed to leave. sandwich starts getting chewed on, and I know. But, so, yeah, common expectation saves time. A lot of the owners like that, and they can plan that way ahead and avoid any type of redos or costly mistakes during installation. And I think we're holding all the questions till the end. All right, thank you.
All right, our next presenter is needs no introduction. Omar from Wyoming has been with the Wyoming DEQ storage tank program for 14 years, 6 years as a compliance inspector and 8 years as the compliance supervisor. He's currently in the Region 8 representative on the Estramo UST Task Force, and interestingly enough, has worked in the environmental field since he was piloting the Exxon Valdez in 1989.
Excuse me. Let's. I said Bud Light, not Hard Right. So I put this together, and it's. I'm not going to go down into the weeds. Okay, I'm just going to get through as fast as we can, and go through what we're looking at when we do tank installation inspections. And I appreciate what he put out, because in Wyoming we do not have a permitting requirement where we have to do a plan review initially, and I wish we could, but under the regs we can't. So anyways, he covered the intro, and here I'll go into the meat and potatoes here. So here's the Grand Canyon of the Yellowstone. We actually regulate tanks inside of Yellowstone, so it's a real tough duty to actually go up there and inspect the tank systems. So initially we have the coordination. We're required to be notified at least 30 days prior to installation or modification. We also remind the installer of the licensing requirements. You would not believe how many times we get somebody calling up and saying, "Oh, I'm going to install a tank," and then come to find out they don't have a licensed installer. In Wyoming, in order to become a licensed installer, you have to pass our ICC W6 storage tank operators exam, as well as pass the ICC U1 exam, and you have to have a current 40-hour HAZWOPER certification. And the reason why is because a lot of times they'll go out there, and if they're doing an installation or a modification, they have pre-existing contamination, and they need to know how to recognize the hazards and how to protect their crew. Anytime work is being done, a licensed installer has to be on site. We also remind them that we have a requirement that all USTs have to have deadmen. We've had too many instances where they go out to install a tank system and they haven't had all the backfill and everything, and the tank pops up out of the ground when we have a flood. Also, we have a guidance document that specifically outlines our expectations when it comes to the installation of tanks. It's called guidance document number 18, and I'll direct you to our guidance document. That guidance document also has the checklist that my inspectors have to use when they're going out there to do the installation, so these installers need to know exactly what we're looking for. We also request the manufacturer's installation requirements, so that involves the tanks and the piping both. Also, the spill buckets will request that as well. Then we install. Once I receive notification of the installation, I refer it to the appropriate program or personnel. So if we're doing an installation in one of our district offices, our remediation personnel also do installation inspections. They do both installation inspections and they do removal inspections. They do not do compliance inspections. We also, so I'll refer it to the person in the district or office personnel, one of my compliance inspectors, or I may actually be the one taking care of it. And as I said, we have to make sure that a licensed installer is on site at all times when the work's being completed. Prior to the inspection, we print out the checklists that we're going to use. We pre-fill all the appropriate information and call to find who the licensed installer is and verify that their license is current. You would not believe how many times we get out there and then come to find out the installer is not licensed or their license is expired, and we say, stop, you cannot proceed any further. Sometimes that actually includes when the crane is sitting there with the tank, getting ready to unload the tank, and we say, sorry, can't install it. So we have 3 phases of installation. Phase 1 is where we actually verify that the tank's in good shape before it goes into the basin, and we also, at the very beginning, before they put the tank into the hole, we actually go around and do a walkthrough around the tank to make sure that everything's good, including the bottom of the tank. So we'll look at a tank like this. Sometimes they'll set it off to the side prior to the inspection so we can actually take a good look at it. We try to find things and look for things like this. This one here was a rock that was kicked up during when it was hauled from the factory. And in Wyoming, it's a pretty long haul from the factory to the actual tank site. In this case, the integrity of the interstice was not compromised. However, most of these tanks are shipped with a patch kit, and we require the installer to patch it in accordance with the manufacturer's recommendations. Here's another example. So when we get the tank and it gets out to site, we get the tank dimensions and we get the serial numbers, such as the UL number, the manufacturer serial number, the tank length and diameter, tank compartment capacities. We also want to make sure that we get the true capacity of the compartments. And one of the reasons why we do that is because when we look at their inventory control records, they're way off because they're using the nominal capacity versus the actual capacity. Also, we get the information on which tanks compartments are manifolded together, and we also find which type of product is stored in each compartment so we can update our database. So when we're out there, we're looking at this. I'm sure this looks familiar to you. Xerxes, there's another one. Let's get the numbers off of those. So then we do a pressure test. We verify, or we make sure that the tank held vacuum, or verify that it holds pressure for an hour with a soak test. The problem we have with the Wyoming is a lot of times these tanks are manufactured on the other side of the Continental Divide, and they bring it over the Continental Divide and it loses vacuum because what the heck? We verify that the vacuum holds on there. Sometimes when it goes over the Continental Divide, they'll lose their vacuum. It's, believe it or not, it's not that unusual for us, especially when you got to carry it over 9,000, 10,000 feet in altitude. So then when we look at the tank install, what's nice about these, a lot of these will have the instructions on the outside of the tank. It kind of makes it a little easier for us too, because we can see we know that the installer knows what he's doing, or at least we hope he knows what he's doing. So prior to the tank set, or when they start to set the tank, we make sure that the separation distances are in accordance with the manufacturer's recommendations or in accordance with RP 100. We also check the deflection readings, and we make sure that, well, I can't remember what I was going to put in there, but I was a little tired when I put this together. Yeah, hard right. Yeah. So the backfill. So prior to backfill, we verify that the dead men are in place, and we also make sure that the metal is coated. And when we're talking about, I noticed yesterday when we were talking about the dead men buckles, generally what will allow them to use rubberized coatings on those. Generally, they have galvanized coating on the buckles. Will allows them to use a rubberized coating, so they'll spray it on there to make sure that it's isolated. Same with the loops on the dead men themselves. We always make sure that they're using 3/4 inch max P or 1/2 inch crushed. And if I remember correctly, that's an RP 100. Also, we'll watch them backfill. We'll go up to about halfway up to make sure that they're actually backfilling properly. One of the problems we've seen in the past, they'll just shoot the gravel out there and not bother tamping it back in around the haunches. That's a big issue because if they don't do that properly, you start getting shifting, or the tank will roll or whatnot. So when I first started, I was going out with our remediation people, and I found out that they weren't actually watching that. And I would watch the installer just go out there and use the backhoe and dump the gravel in the hole and never tamp it in. And that's really an issue because those sites that I saw them doing that when I first started, I didn't know any different. And after going back there, the tanks have started rolling and shifting. So that's something you need to watch when you're out there. So here's an example of the Deadman. This is actually an install I inspected here several months ago. There's another one. That's one of my favorite parts in the state. That's actually Hoback, the Hoback River Valley. Oh, it's just gorgeous up there. I wish I could go up there every time. Next time I go up there, I'm taking my fly pole. Might have to take a little bit of leave for a couple days. There's another thing that we see. I was driving down the road. I was in the middle of nowhere, and I go, "Did I just see that?" You know, and it's out there, and I mean, this is total deadlands. And I think some rancher just decided they were going to have fun with people to actually see if they were paying attention. Yeah, So on the Phase 2 installation inspection, we get out there and we know which type of piping they're installing. All new and replacement piping must be double wall and interstitially monitored. We also recommend if they're using flex pipe that they use a chase. And when typically we loosely call it rock guard, but I know that's an industry name. But the reason why we recommend that is because, as well as most of you are aware of, with these old TC total containment pipe failures, if they were smart enough to use a chase, they were able to pull that pipe out and then run it back. And that's why we highly recommend that, because in the long run, if that piping fails or if they have an issue with that pipe, they can run that back through without having to cut up concrete and excavate. Also, we tell them that they have to have under dispenser containment and tournament sumps. Piping configurations, sensors. We require them to put sensors to be placed at both the dispensers and the turbine sumps. We put in there that you don't have to determine slope. It just makes it a little easier for us. So we want to make sure that the product gets back in there. I know RP 100 I think says that you have to have an 8-inch slope, if I remember correctly. Sometimes the manufacturer says you don't have to, and unfortunately it says in our regs that it can be in accordance with RP 100 or in accordance with the manufacturer's recommendations. If they're doing FRP piping, we want to make sure that the epoxy is kept warm. I'm sure some of you in these colder states probably have seen this before in the past. What your manufacturers will tell you is that the epoxy has to be kept warm. It can't be below, I think, exposed to below 32 degrees, if I remember correctly. And we've actually gone out there and gone to an installation inspection, and the installer's got it sitting over in a snowbank. So that's not very good. Also, we make sure that the piping runs are continuous unless there's a transition sump where the connection is made. We want to make sure that the interstice is continuous from sump to sump. Piping testing, we do the pressure test of the primary of 150% of operating pressure, and then we also pressure test the secondary no more than 5 psi. Generally, the range is between 3 and 5. Also, we make sure that we soap all the fittings to make sure that it's holding pressure. one thing that we always do is the first thing we do is actually make sure that we soak that stuff to make sure that it's going to hold pressure in the long run instead of waiting till the very end, because we have to watch it for an hour. Then what we do is we release the pressure on the primary to show that the gauge works. Pressure should be maintained on the secondary after the initial or the phase 2 inspection, just to make sure that the piping's not damaged during backfill. Another thing that we do is on the primary, when we release the pressure, we go to the very end dispenser and release the pressure to make sure that the gauge at the far end of the tank actually decreases. The reason why is we want to make sure that piping run is continuous. So there's pressure tests, the piping with the UDCs. So the sumps and under dispenser containment, we make sure that the sumps filled with water 4 inches higher than the highest penetration, and the water level should remain constant for an hour. We also check the exterior piping penetrations and feel for liquid. We also make sure gauges are at the end of piping to release pressure at the end to show continuity. Shear valves. There's one that's nice. Notice the ice on there. Nice winter inspection. And what really cracked me up when I looked at this real close, you notice he's got his sump sensor already connected and it's underwater. So there's the Tetons. This one here was kind of interesting. I don't know what it is, but the Sinclair stations, they like to decorate their dinosaurs. I thought it was kind of funny. I really like the eyeballs up here. That was pretty cool with the party hat. So then we go to the phase 3 inspection. They call us up and they're ready for the phase 3. This is the final installation phase of the inspection. So we check the spill buckets. We do an integrity test in accordance with the manufacturer's recommendations. If it's a double-walled spill bucket, almost all the manufacturers recommend a vacuum test. Initially, when we first started seeing these, we didn't realize that the manufacturers did a vacuum test and we were just requiring a hydrostatic. Also, we require a hydrostatic test to the primary. Here's another one. Keep this in mind on these double-walled spill buckets. Some of them, they have a test port for the vacuum on the interstice, and what happens is somebody doesn't put a cap on that. And we've actually been seeing where they'll put the fuel cap on there and come back a couple of weeks later and they've had a massive rain event and somehow water gets down in there and it actually gets into the interstice on the spill bucket. Well, we go out there and look and it's actually pegged out all the way to the opposite side, and the operator thought, oh yeah, it's empty, but actually it was full. So we need to make sure that those are plugged up. Also, we don't allow catchment basins. If we see them, we just tell them no. So here's the hydrostatic test. Piping. We want to make sure that the pressure should have held on the secondary on the piping. Like I said, we release the pressure at the opposite end of the run from the gauge to make sure that the gauge has not been stuck at the same level. I've seen this happen at least 7 or 8 times where the actual gauge, the needle gets stuck and you release the pressure and it's stuck at the same position. So it's something else you need to watch out for. We either have them loosen the hose clamps or just slide the boot back, or we have them remove the Schrader valve from the valve stem on the test boot. And we also make sure that that stem's pointing down so it actually drains down into the sump. Here's another one where you see the jumpers. We get the automatic tank gauge information, we get the serial number, the model number, and then we get a system setup printout. That setup printout is very important because we get calls all the time saying, oh, my ATG's shot. Do you have the setup information? And fortunately we do, so they don't have to go through the manufacturers and whatnot. We generally have it scanned at the office. We go through and do the function testing of the sensors. We check the tank interstitial probes. We check the sump sensors. And we also tell them that they have to function test the sensors using liquid. We've been finding lately where they actually don't, the float's damaged, and just flipping it over doesn't work because you got to make sure that that float actually floats on liquid. We also get a printout showing that the function test was completed. So here's a good example. If you look, all of these show that the fuel alarms are going off. Overfill devices, we want to make sure that they're function tested and documented. We also say no ball float valves or wire hangers. Notification requirements. So when we require an installer's oath, so the installer actually certifies that they installed it properly in accordance with the manufacturer's recommendations and industry practices. We also provide the owner with a registration form. Generally, they'll fill that out beforehand, but if for some reason they haven't completed it, we'll provide it at that time. We also inform them that they have to perform tank leak detection by obtaining a sensor printout each month. We've had this problem before in the past. We want them to show that they're actually doing detection by looking at the system and make sure it's not alarming. So we generally require a liquid status printout each month to show that they're doing interstitial monitoring. We also inform them they have to perform what we call an operator's annual inspection. One thing in Wyoming is we require what's called an operator's annual inspection. And during the operator's annual inspection, they have to do all the testing that's required, such as line tightness testing, leak detector function testing, sensor function testing, and if they're due for CP testing that year, they have to do the CP test at that time as well. They also have to inspect all of their equipment, open up dispensers, all that stuff. They have to document it, and they also have to submit copies of the previous year's tank leak detection records. So that's why we're talking about with the operator's annual inspection. A lot of these people don't know it when they do get their tanks installed. We also notify them that they have 90 days to obtain an operator's license, or an employee it's either the owner or the operators have. Somebody that's an employee of the company has to obtain a license. We also inform them they have to pay their annual tank fees, which is $200 per tank per year. We also regulate ASTs that are used for retail purposes, and if the ASTs are less than 5,000 gallons, they only have to pay $50. This is really nice. This is up by the Miracle Mile. It's a gorgeous area up in there as well. So, in summary, if you want to find information and take a look at our guidance document, it's guidance document number 18. It also has all the checklists that we use. Used to be we had like a 70-page checklist. Now I knocked it down to about 30 pages. It's on our website. If you want to get information regarding our program, you can Google DEQ STP. I use that as the catchphrase because it's a storage tank program. You can get on there, and over to the left-hand side under Program Resources, you'll see a thing that says Guidance Documents. You can click on that, and you can look at Guidance Document number 18. I think we also have Guidance Document number 20, and then we have Guidance Document number 28 regarding spill buckets and catchment basins. So this is my last rodeo here on the task force, and that's a jackalope. And with that, I will ride off into the sunset on my beautiful jackalope. These things are getting so boring.
Our next presenter is Todd Bogenreif, who is currently the Midwest and Western Canada Regional Manager for Containment Solutions based in St. John, Indiana. Todd joined CSI in 1995 and held various positions, including the Midwest Area Manager, before becoming the Regional Manager in 2013. Todd was previously employed by the Owens Corning Fiberglass, Chris Craft Industries, and Nalco Chemical Company from 1982 to 1995, and holds a Bachelor of Science in Packaging Science from Michigan State University in East Lansing, Michigan.
Morning. I'm going to start by saying, first of all, that in Indiana we have nothing that looks anything like what you showed us, so I'm a little jealous. We're going to take a little bit of a left turn here. We're going to talk about, so far you've heard about new installations and some of the processes you go through. What we're going to look at now is, with existing older fiberglass tanks, a process that's available to actually bring them into a point where they are now compatible with some of the new fuel blends that are out there. Before I even begin any of this, I want to preface everything by saying, first and foremost, we're a tank manufacturer. We like supplying new tanks, but we recognized that there was a need for some of our customers that had existing tanks that wanted to use some of the newer fuel blends out there to have a process to actually convert that tank so it could be used and would be compatible with those new fuels. And it appeared to us that in the marketplace, a lot of the processes that were being utilized up to that point were less than desirable in terms of their stability and their durability. So we set out to look for something that we would be comfortable with, and in typical CSI fashion, we probably over-engineered it, but that's where we like to be because we're comfortable with it. All right, so I'm going to give you a little background on where we started and the process we went through when we developed this, the test methods we used, and then we'll look at the actual process itself and who's actually doing the installations. Right, so in 2007, we actually had our discussions in 2006. We introduced this new product. It's available for both single and double wall tanks. We do not do this for steel tanks. This is strictly for fiberglass tanks. It takes about a week for 4 technicians to come in and do a typical site where you might have 2 or 3 tanks. A little less than that if you just got a single tank that you're trying to upgrade. Our CSI technicians perform all the work. We're not third parties sending third-party people in to do this. Our technicians are the ones who are going to perform any of the work that's being done on these. The standard that we looked at for our design was the API 1631 standard at the time. And remember the over-engineering I was talking about? Our tank is actually 33% thicker. The internal upgrade that we're doing is 33% thicker than the API standard required. It's compatible with the biodiesels, per ASTM D6751, all the ethanol blends up to and including 100%, ultra-low sulfur diesel, meets API standard 1631, the NLPA standard 631, and then the Fiberglass Tank and Pipe Institute T9502. When we did this, we worked with John Clark Engineers. I'm not sure how many of you are familiar with them. And if you recall yesterday in our presentation, they are an associate member of the Fiberglass Pipe and Tank Institute. John Clark and his group as a company. John Clark actually used to work with us or with me at Owens Corning years ago as one of our engineers. And he designed a lot of those protocols. But John, it's important to know that with John as a third-party certifier, he was selected because of his background. John, when he was with Owens Corning, was responsible for a couple of the patents that Owens Corning held, including the design of the double-wall storage tanks, and then also the tank upgrading method for tank assembly. So that would be any work that was done in the field for installing new manways, new fittings, deflector plates, any of those kinds of things. He was involved in all those processes. So the final report concluded that CSI's data was consistent with or actually exceeded all the API standards. I was certified by John Clark. Some of the tests that we went through in the process was the ASTM D970, which is flexural strength. Did 282 of those tests. The impact resistance test, 51. Barkle hardness, 374. Visual and dimensional changes. And we're going to look at all these a little closer, 376, and then bond strength, which is probably the biggest of the factors. We did 49 of those. So in addition to the 11 standard API fluid or API test fluids, I'm not going to read through all of them, we actually went through a number of additional test fluids, which included the E85, E70 are 30%, 15%, 30%, 50%, 100% ethanol, 100% biodiesel, and then 30% butanol and 70% unleaded gasoline. So those are some additional fuels that we did testing on. The API test involved immersion testing of our coupons. You can see a sample here where you're actually immersing the coupon samples in a bucket, putting the whatever fuel it was, and again, we did all those fuels you saw in the previous slides. Those are then stored in an oven at 100 degrees, and they're tested at 1, 3, and 6 month intervals. This is a quick look at the ovens that we have outside of our facility. So the first test we did, again, 282 tests, is the flexural strength. It's basically a 3-point test. You get another picture of that. If you look at this picture closely, you can kind of see, if you look on the bottom edge of that, that's actually the upgrade material that's been applied to the original materials. You can see a slight difference in the coloration there. So this test it looks fairly simple. Put it on 2 points, press down and see how hard it has to be pushed before you break it. Then we did impact testing. A little bit deceiving here. The impact equipment itself is actually on the right side of there. It's just kind of hanging there. We drop it down through the tube. You can see the gradations on there, so we know how high that is off the piece that we're dropping. And the nose of that is a 1/2-inch diameter nose that drops onto the piece of fiberglass. It drops down through that tube, impacts the fiberglass on the surface, and we measure that impact resistance of the fiberglass. And you can see here where the little circles are, you can tell where that impact has taken place, and you can see the indentation where it took place. And then we did Barkle hardness testing, which is basically just measuring the hardness of the surface of the new material that's been applied to the existing laminate. And then dimensional changes, basically each sample that we did, we took a dimensional measurements, the length, width, and thickness before they were immersed, and then you measure those again and compare them to look for changes after they've been immersed. And again, 1 month, 3 month, and 6 month at elevated temperatures with all those different fuels we looked at. And again, you can see on the side view, you can see the upgrade material is a slightly different color here, just so we were able to identify it in the field. We actually use the same color resin as we would on our normal tanks, so it's a little harder to see. I did, for later, I brought a sample. If anybody wants to feel and touch, it's up here on the table. You can take a look at it. The last test, and again, I think probably the most important of the tests that we did for API, was the bonding strength. And what you'll see here is what they call a dolly. That's actually applied to the surface of each of the samples, and we did 4 of them on each of those. You then cut around that to get down into the original material of the tank. And then basic test, you pull to see how much force it takes to pull that off. This is the equipment that's used for it. And this is the result when you're done. And what you see here is you see where a lot of those dollies were actually pulled off as opposed to the laminate structure itself pulling apart. And what's important to know here is that the adhesive we use to attach those dollies is designed in such a way that it is actually going to exceed the amount of force that we feel is required for the bond to be good. So if we're pulling the dollies off, that means that the tank laminate itself and the bond with the new material exceeded what we were looking for. Some of them you see where it actually tore, it's kind of hard to see in the pictures, you can see where it actually literally tore the fiberglass material apart. What's important to know for those, and if you look closer, you can kind of see on the front, you can see that darker surface for the new material is not where that failure took place. It was typically in the original tank laminate that it failed. So the bond itself did not fail. The tank failed before the bond did, which tells us that laminate that we put on the tank for the upgrade is actually bonded stronger than the original tank wall. So the process itself, fairly straightforward. The tanks are inspected and valued. They've got to be cleaned. We typically work with a contractor locally to make sure that they're exposed so that we can enter them. If they don't have manways, well, actually the very first thing we have to do is put a manway in it so we have access to the tank. Once we are actually able to enter the tank, we do an inspection. And I will tell you up front, if we enter a tank, do the inspection. If that tank does not look like it's suitable as a candidate for upgrade, we're done. The next conversation is going to be about replacing that tank. Assuming the tank is okay and we're comfortable with being able to go in and do the upgrade process, we move on from there. Inside of the tank is completely abraded, typically using a sandblaster. Sometimes you get a smaller tank, they might choose to go in and actually use an air compressor grinder to get in there if it's smaller. And there's some of the nooks and corners they might do that, but generally they're going to use the sandblasting process. All the fabric or all the layup materials and stuff are cut prior to coming to the job site, but the actual wet out of the fiberglass material is done on site. And what will typically happen is you'll have two gentlemen, two of our technicians, they'll be up above, and two of the technicians in the tank. And then they'll always have a contractor supply a safety person on site. So our 4 people are working. We have a safety person who's a third-party contractor. So one wets out, one's moving those back and forth, 2 technicians inside the tank. And they're installing those laminates on the interior wall to build that wall up and create the new inner wall of that tank. Once it's cured, they'll go in and they'll put in new deflector plates, fittings. Typically with the fittings, we like to put those all in the manway so that they're easily accessible. Now that being said, we can do them in the tank wall if we need to. But we try to encourage them to just put everything in the sump on a manway because it's just an easier process, takes a little less time, but we can do it the other way. When they're done doing the layup, they got all the pieces and parts in, got the new fittings in, they'll do a precision tank test. But we also require them to then have a third party come out and do a precision tank test after we're done to make sure that it's been certified by someone other than ourselves to make sure it's tight. Once everything else is done, sumps are put on. One advantage to having our field service technicians do this is we don't actually put a collar on, have somebody come in. They just literally put we cut the sump so it has a saddle, so everything just gets put right on top of the tank. So new sumps are put on. All the penetrations and everything go through there. There's your finished entry with the fittings and the manway cover. And you now have a tank that is designed for all the new fuels, and we do put a 10-year warranty on that. Wanted to put this in here. I know there's a lot of discussion about ultra-low sulfur diesel and some of the corrosion issues that are out there. One of the options that is available when we do this process, and actually for any existing tank if you wanted to, would be to come in and upgrade those to change the fittings to stainless steel or to use stainless steel manway covers to eliminate certain points of corrosion that might be an issue. When it's done, again, what we go back to is this upgrade process, that new material on the inside of the tank, essentially what we've done is we've made the tank wall thicker. It is now a permanent part of the tank. It is not going to delaminate. It's not a dissimilar material. It is permanently attached to the tank. The only way it's coming off is to go back in with a sandblaster and braid it off. So it is now just part of the tank. We actually have to go in and revise our tank calibration charts to allow for the fact that that tank is now about 1/4 of an inch less diameter than it was before we started. Give you an idea where our technicians are: California, Indiana, Pennsylvania, Texas, South Carolina, and Florida. The yellow stars indicate where our field service managers are at, and they're the ones who coordinate all these processes. All of our technicians, and again, I talked about how our technicians that are coming out to do this work, they all go through HAZWOPER. They all go through all the, I'm not going to run through the entire list, but safety is paramount for them. They go through a lot of training every year. They're always up to speed. So there are some of the ones that aren't listed here are picks, and some of the other ones that are required for us to work on job sites for some of the major oils, and those we go through all those every year. So every one of our technicians is trained and certified in all these safety applications. And that is it. And again, I would invite you when we're done, if you want to touch and feel, I'd pass it around, but it's kind of heavy.
All right, thank you, everybody. Before we get started with the questions, do want to remind everybody that the nice little pink evaluation forms, if you haven't filled one out, please fill those out. It lets us know with the UST group how we can make these conferences better. Comments, concerns, wants, and needs. If we don't know, we don't know. So with that, we'll open up the floor to questions.
I have a question. I guess it would be for Todd, but it could be for anybody in the room, actually. You had one of your slides showed the list of fuels that have been part of the testing, and I am interested in this new set of R fuels, the renewable fuels. I didn't see that on the list anywhere. What can you say about that group of fuels?
My understanding at this point is that they're testing those. It wasn't on the list. Those have been tested. Anything new that comes out will be tested. I mean, we try very hard to be ahead of the curve when it comes to new fuels that are coming out. But as you saw, anytime we do a test, you're looking at a minimum 6 months as far as just the samples themselves, and then you have to compile all the data. So they'll go through and do all that testing as those fuels become available. And, once we become aware that a fuel is something people are looking at, we do the testing on those.
Right, because that whole group of fuels is pretty new, I think. And
Yeah, a lot of them.
are there any states that have any wording and rule or anything about this R fuels and compatibility? No? Okay.
They had tested for that. They said, I'll get back to you. They haven't yet. Just something to think about.
Hey, Carol. Go ahead.
Quick question for either Michael or Oma or anybody else in the room who would care to answer. Just wondering if you've quantified the cost of doing an installation inspection in your state?
In Wyoming, we actually charge a $250 inspection fee. But generally, you're talking about the cost of actually doing the inspections. It just depends on where the locale is and how far the inspector has to travel. Most of the time, because our remediation personnel are doing some of these, we have 3 different district offices, and generally it's just a day trip. So you're probably looking at your man hours and your travel costs for the vehicle, and generally that's it. So, it's not a major expense for us. We probably do 50 installation inspections a year, so it's not a major cost to our budget, I don't think.
Michael, any idea what they cost to do?
Sure. The only fee we charge for the underground storage tank program is a whopping $100 plan review fee, which, of course, doesn't really cover any of the overhead. We have 3 personnel full-time who are in our plan review section that review the plans and go out and perform the backfill and the final operational approval inspections.
So you don't really have a cost accounting number, though?
Well, we have the folks there, and depending on the amount of inspections, they go, I suppose you could divide it up by that. But if they're not doing installation inspections, then it'd otherwise be at both facilities doing operational compliance inspections.
Okay, thank you.
And in Washoe County, which is one of my third-party counties, they just got it approved last year, they charge $1,500 per install to have somebody out there.
Yeah, I would think the actual cost is more in that neighborhood than $250, but just guessing.
Got to remember that statute for that $250 inspection fee came in 1990.
Yeah, go ahead.
For the states that require piping to be sloped, how do you allow, or how do you deal with the OPW flex loop system? The flex works.
We don't allow it.
You don't? Okay, fair enough. The other follow-up question I have is for Mike. You said basically repairs have to be signed off by the manufacturer, in essence, or a letter?
Correct.
What do you do if the manufacturer is no longer in business?
Right. That's a little bit of a gray area where we look at common codes of practice, and we basically make a determination whether or not that repair is going to bring it to the original capabilities or strength of that system.
Fair enough.
Okay. So I have a question for Todd. Todd, and in the interest of full disclosure, I am with Steel Tank Institute. So, for the biofuel upgrades, was it not UL listed?
The biofuels?
The upgrade process. You said it was third party approved.
It was third party through John Clark Engineers.
Okay.
So, and they just certified the API testing that we did as a third party.
Okay. But the API is like a recommended practice. It's not like okay. I haven't looked at it for a long time, so I'm just trying to make sure. Did you do any permeability testing as part of that?
Permeability is really addressed when you look at the immersion samples. I mean, there are other studies they do. I mean, we know the original laminate of the tank
was because we went through all the original design for UL 1316, which talks about permeability. So we really weren't concerned about permeability because we know what the primary tank was about, and we knew that the materials that we used were similar. All we were looking for really was to make sure that that bond of those two materials was going to be up to the standard that we were looking for. The materials themselves, as the resins, were already approved. So that was another process that we go through for approving those materials for use with those fuels, independent of the API for the BTU process, because that was really more of a structural test to make sure that the upgrade on the inside of the tank was going to meet the structural standards that we were setting.
Okay, I thought it was more about the compatibility with the newer fuels.
Well, the resins are already compatible. Again, that goes back to other testing for other methods that we did. So we know the resin system, which is an isophthalic compared to polyester, was already compatible. We've done other testing through UL for 1316 for those resins. I mean, it's the resin systems we're currently using in our tanks.
Okay. Okay, thank you.
This question's for Todd or any of the other states. In Maryland, we've been experiencing concerns with our remediation division have been observing during the removal of the older fiberglass tanks, 1981 and before. Unexplained contamination. The tank shell looks like egg shell. It's so thin, and deformation in some of the tank walls. Is anybody else experiencing this? We sent out compatibility letters to all of our tank owners, and we're down to now about 150 remaining tanks that we're trying to address. Anyone experiencing unexplained contamination at these older fiberglass sites that they're addressing?
So, I guess contamination in what way?
Soil contamination. We're seeing obvious signs of sheen on the side of the tank, on the lower portion of the tank. Yes.
Okay. Yeah, I have to be honest, I've not heard that. So this would be a first for me to have heard that. That would be, I certainly be interested in looking at it to see if there's an issue with them. Whether that came with permeation through the tanks or whether it was, spills during filling from older tanks that was just still present would be, that'd be hard to determine. But permeability of fiberglass with the fuels is, I've not heard that has ever been an issue. And what we typically saw even with the older tanks and some of the newer fuels is generally what you'll see in those tanks is you'll see some discoloration on the very surface of the tank, but if you sand down, it's really on the very surface. It doesn't even get very far into that tank wall at all. So you get discoloration, and actually at that point it actually hardens the resin system at those points. So without being there and knowing, I'm just guessing, but I'm guessing that it's probably coming from someplace other than the inside of the tank, because I've not heard of any permeation issues with fiberglass tanks.
Question for Michael. You mentioned in the pre-installation inspections that there's tank within the tank. On some occasions, the building. I'm assuming you're referring to the Phoenix system, and I don't remember the name of the other company. But and my question is, how much demand from owners is there to do that, and what types of tanks is it being done on?
Yeah, there isn't a whole lot of demand on that. It's kind of a niche. If you have a tank farm, say 3 tanks at an underground storage tank or a gas station, and say one of those tanks has an external wall failure, rather than trying to dig that up, it's more cost effective to go into that one tank and install a new tank within that. And that's the only time we've ever seen the field erected tank installations.
Can you give me a rough guesstimate of how many there's been?
Yes, we've had 3.
Okay. We're right next door in Maine, and we have that in our rules as an option. There's a whole lot of caveats to it, but it is an option for getting a 10-year extension on operating a single-walled tank, and we think it's probably cost prohibitive. There's been, so far, no interest in it whatsoever, but I was just curious. Thanks.
I have a question for Todd. I think you mentioned you'll do an internal inspection of the tank prior to deciding to line it. Do y'all have any criteria that y'all use even prior to that, as far as tank manufacturer or age? And I'm kind of most concerned on tanks that have already been determined to be not compatible with even E10 fuels, and is there certain?
Yeah, I mean, really, it was designed for those older tanks. You get the real old ones, and you have to get real. I mean, you're talking something that's not compatible with E10, you're getting really old. Don't see a lot of those where they're actually looking at trying to keep those tanks. More often than not, those tanks are going to pull. But from a practical perspective, as long as that tank is structurally sound, they wouldn't have an issue with it. That's going to be a single wall tank. Anything that was that old is going to be single wall to begin with. So depending on what your rules and regulations are, you have to determine whether you can use it. It's kind of like with the other options you have out there. It's a little bit of a niche, but it does give them an opportunity to go in there. But they will do a very thorough inspection to make sure that the tank is still a viable tank. Tank that old, fittings are obviously going to have to come out. It probably doesn't have deflector plates if it's that old, unless they've gone back in and put them in. So they will look at it, and like I said, we've walked away from jobs once we get in. It's hard to determine, other than doing a tightness test on a tank, anything else until you can actually enter the tank and take a look and see what you have. So, but again, we're not bashful about getting into something and saying, nope, this is not where we want to be.
Sure. Yeah, I just have a follow-up on that. So y'all have been lining since 2007, and that's when the Energy Policy Act came out and required everything that's new or upgraded to be double wall. Is the lining considered, in the states that you've done it, a repair or an upgrade?
A little bit of both. Now, we consider it an upgrade because, like I said, once we put it on there, it's a permanent part of that tank. I mean, all we've done is make the original tank wall thicker. It's not going to come off. So, I mean, we look at it as an upgrade.
Okay.
I mean, and I guess that would be my point for this whole presentation is, to us, it's an upgrade. It's a permanent part of the tank. It goes on just like adding fittings and collars and manways. It's not coming off once it's on there. So, and again, when we looked at it, we were looking for an alternative to the typical lining systems that were out there. We had dissimilar materials that you were trying to create a compatibility system through, but without the issues that you have with it.
So it essentially eliminates the single wall tanks?
It would still be a single wall tank. It would just be compatible with the fuels. And if it's a double wall tank, it's still double wall. It does not have an annular space. I mean, it is bonded directly to the internal wall of that tank.
Thanks.
Hi, good morning. Great presentation, folks. Just wanted to touch briefly on something that Todd and I discussed briefly yesterday. But Todd, do you guys do full weight capacity test on fully constructed tanks? And I say that because in Connecticut, like I'm sure in many other states, we have a lot of truck stops. So we're concerned with what we call the oval out effect of having a tank that's fully constructed where you have a capacity of weight that may be compromising the integrity of that tank. And obviously there's going to be a consideration with how deep you'd install that tank given the application or which type of facility the tank is being installed. So that's to Todd and to Omar and anyone else that might want to touch bases on it. When you guys are doing inspections at these installations, do you take into consideration what type of a UST facility it is and where they might have a different requirement for burying the tank deeper, and whether that would possibly affect inspection of the sump?
The short answer for us is we designed H20 axle loads. If you look at our installation instructions, there are guidelines to how much overburden you have to have above the tank with or without a concrete pad to meet the H20 axle loads. And as long as you follow those recommendations, you'll be fine for those. And when you and I talked yesterday, standard fiberglass tank with 3 feet of backfill material over it meets H20. That doesn't even have a concrete pad. You put a concrete pad over the top of that, the amount of backfill material is then reduced, and you still meet the H20 requirements.
On the installs, we actually go through and look through our RP100 burial depths, and we also look at the manufacturer's recommended burial depths as well. Every manufacturer will have different burial depths as far as what your concrete depths are and whatnot. So
Yeah, we do the same thing. We look at the manufacturer's recommended depths, both for the tanks and for the piping. Piping is a big thing. We oftentimes see folks try to install it too shallow, and we pick that up in the plan review.
So this is Mark. I just want to follow up on a question about, is it an upgrade or is it a repair? We're actually in the process of writing a Q&A on this specific issue as well, and sort of all the different types of tank within a tank type technologies. And the term upgrade in the federal regulations means something very specific, and it has to do with bring your tanks in compliance with the corrosion protection requirements. So we wouldn't call it an upgrade. But a repair for us is, an association with the release or something like that. So it's something other than both of those. Is sort of where we're ending up. It's an improvement, or I don't know or modification or something, right? So it's not an official term that triggers something in our regulations. Just wanted to follow up on that. At least that's where we're heading on this, because upgrade means something specific, repair means something specific, and this is something else altogether. Yeah.
There you go.
For Todd, I was wondering, for the coupon testing that was done, you included methanol. I was curious as your thoughts behind including that.
That would be one that our R&D would have to do, but you still see some applications where somebody wants to be able, and from just on the other side of our business, and it's a chemical storage, we still get requests to do fuel tanks for methanol, and not actually fuel tanks, but chemical storage tanks. So my guess would be that R&D just wanted to see how it would perform using that material, and I agree, you don't see it out in the marketplace anymore as a fuel, but it's still on the list, and so they did test it.
Okay. And then a quick comment, too, following up on Michael's presentation about identifying public wells as well as private wells and looking at setback distances. We're be coming out with a publication soon to identify and update locations of private wells based on census data and construction permit data. So that publication will be out soon, and we'll have this out. We can distribute it through OUST to the folks who are interested in that.
This is for Michael on the self-structural tank, and for anybody who's considering allowing these companies. And I believe you have the same contractor in New Hampshire as we have in Illinois, and we've probably got 20-some now in Illinois. And we had the same experience with you. They sold us on the UL 1316 listing, and the experiment with the tank that was taken out of the host tank and evaluated standing on its own. And then they started installing tanks that used the original tank top. They did that once, and we let that one go. But we require them to put entire, like you did, 360 degrees tank with the new laminate, new bungs, new manways, and everything has to be incorporated into the new self-structural tank. Because what they were marketing was a self-structural tank, but what they were going to deliver was a co-structural tank.
Yeah, and they expressed to us at the time that that's how they did it everywhere, not the complete 360.
They say that to everybody who challenges them.
Yep.
They also said that no other states were concerned about federal OSHA confined space regulations except Illinois. I was skeptical about that. I said, you realize those are federal regulations that apply across the board, all states. So,
yeah, you got to state beware. You got to keep an eye on these installations.
We have an inspector there for the entire weekend, a few days.
Todd, can you describe your travel partner in front of you?
Oh, this is it's just a sample of the BTU laminate laid up, and we did it actually in a way that you can actually see where that transition is from the original tank wall to the BTU laminate that was applied to it. So we did it in blue. Like I said, in actual practice, we just use the same resin colors that we use in our regular tanks. This just lets it stand out. And like I said, I pass it around, but it's a little heavy.
Any other questions out there?
Just one quick one. I noticed Maine said that they do not allow flexible piping. And is there any other states that ban flexible piping in new installs? And what type of?
No, we don't ban flexible piping. It has to have slope.
said they don't allow it. Okay. Now, one more question in reference to flexible piping. I know a lot of times we're concerned with not really having true as-built about where this piping is located. You guys know when you're looping piping, you got a bend radius, and a lot of times this piping is, I'm sure you guys probably seen some new installs where you got this figure-8 formation with this flexible piping trying to hit all of these dispensers, and a lot of times when we're concerned with future geoprobing, where
That's when
we
they
don't
usually
know
find it.
where the piping is.
That's when they usually find it. Just when the geoprobe smacks through it. Then we have a real confirm release.
Exactly. But we have had that concern. And has any other states had concerns over installation of this flex piping and not really with some type of diagram or layout properly documenting where it is in the tank pad?
Florida's new rules require anything that's below grade to be surveyed in by a professional land surveyor, period. Cannot be blue line drawn up by the site constructor or anybody else. It has to be a professional land surveyor for anything below grade.
Maine's rules require the owner of new facility being installed to maintain as-built drawing, diagram, etc. They don't have to submit it to DEP. I'm not. We don't really know if that's stringent enough or not, but there's that for a start.
Yeah, one of the things we do, we require the record drawings to show where the piping is. It's not as stringent as having a licensed land surveyor do it. They're pretty close, but what we do is we take a whole lot of pictures when we're going out for the backfill inspections from all angles, and just it helps us also catalog and exactly what type of fittings, whether or not there's what type of adhesives may be visible from the installations and things like that. Just so we keep those pictures not on a main database that's accessible by one stop, but we just keep them on an internal server and save those just for posterity. You never know when the question's going to come up, when there may be a failure at a facility where you need to look at those details.
You would think that it's not too challenging to possibly put a tracer surface in the wire so you can be able to maybe find it, but we found that they use like this small thin metallic layer that's not necessarily picking up with our metal detectors because of the tank pass. So we're trying to find this piping and we're not able.
Yeah, they usually use that little metallic paint, that tape, all over the place. Let's be honest, we all have building codes, we all have city codes, county codes. I mean, it's kind of a mismatch out there. But, I mean, more often than not, the owners know where they need to, they'll usually know where it is. But you got second, third, fourth generation owners, who knows where the piping is at that point. Seeing no more questions, just remind you with the evaluations, you can leave them at the check-in desk at the front, and we'll be back at 10:30.
Good job, Don.